In 2010, the state of Washington made a decision that quietly rewrote the fate of millions of household machines. They banned a chemical, sodium tripolyphosphate, from dishwasher detergent. By July 1st, 2010, 16 other states had followed: Illinois, Indiana, Maryland, Massachusetts, Michigan, Minnesota, Montana, New Hampshire, Ohio, Oregon, Pennsylvania, Utah, Vermont, Virginia, Wisconsin. One by one, the map changed. Every brand on the shelf shifted at the same time. Cascade reformulated. Finish reformulated. Everything you could buy in a grocery store, different overnight. The explanation sounded clean, responsible, necessary. It was for the environment, and that part was not a lie. In parts of the Pacific Northwest, lakes were suffocating. Phosphate runoff fed massive algae blooms. The water turned green. Oxygen vanished. Fish died. Treatment plants could not keep up. Scientists had a name for it, eutrophication, but the reality was simpler. The lakes were dying, so regulators acted. But in pulling that chemical out, they removed something else, something no one explained, something that had been quietly protecting every dishwasher cycle for more than 50 years. And the machines started failing, not because of cheap steel, not because engineers forgot how to build, not because of plastic tubs or manufacturing shortcuts. This was different, something invisible, something happening inside the machine every single cycle. To understand it, you have to go back. Early 1950s. A chemist inside a Procter & Gamble lab in Cincinnati is staring at a stubborn problem: soap scum. That gray, waxy residue left behind when soap meets hard water. American tap water carries calcium and magnesium. The harder the water, the worse the residue. Those minerals bind with soap. They ruin it. The chemist needed something stronger. They found it in a salt, sodium tripolyphosphate, STP, a chelating agent. The word comes from the Greek for claw. And that is exactly what it does. It grabs calcium ions, locks them in place, and keeps them from interfering with the detergent. The soap stays active. The water behaves as if it is soft. The dishes come out clean. In 1955, they launched Cascade, the first automatic dishwasher detergent built for a new era of kitchens. It contained about 30% STP by weight. It worked. It worked so well that within 10 years, every dishwasher detergent in America followed the same formula. For decades, this chemistry defined clean dishes and quietly protected the machines themselves. Then the lakes started dying. By the 1970s, phosphates from household drains were showing up everywhere, in rivers, in lakes, in ecosystems that could not absorb the load. Phosphate is fertilizer. In small amounts, it feeds life. In large amounts, it overwhelms it. Algae bloomed out of control, then died, then decomposed. And in that process, they stripped oxygen from the water. Fish suffocated. This was not theoretical. It was measurable, visible, real. Under federal pressure, detergent companies removed phosphates from laundry detergent in 1994. Laundry was the bigger source. And slowly, the lakes began to recover. Dishwasher detergent remained unchanged. It was a smaller contributor. Most ecosystems could handle it. So for 16 more years, the chemistry stayed the same, about 8% STP in every cycle, doing its job quietly, until Washington stepped in. And everything changed. What disappeared in 2010 was not just a cleaning agent, it was a shield. Inside every dishwasher cycle, water heats to around 130 degrees Fahrenheit. It moves fast, under pressure, carrying dissolved minerals, calcium, magnesium, through every internal surface. Without something to bind those minerals, they fall out of solution. They settle, they harden, they build. The first place they strike is the heating element, a metal coil sitting at the bottom of the tub, responsible for raising water temperature and drying dishes at the end of the cycle. When mineral scale forms, it looks familiar: white, rough, layered, just like the inside of an electric kettle. Each layer forces the element to work harder, more energy, more stress, less efficiency, closer to failure. Then the pump, a plastic impeller spinning at speed, pushing water through spray arms at roughly 12 gallons per minute when new. But scale does not care about design specifications. It clings to the blades, it thickens the edges, it disrupts flow. By year 3, that pump may drop to 8 gallons per minute, quietly, no alarm, no warning. By year 5, the motor strains under the load, heat builds, bearings wear. And eventually, the pump fails. And it does not stop there. Scale invades everything. Spray arm holes narrow, water inlet valves clog, float switches stiffen, fill solenoids struggle. Every moving path for water becomes a friction point. Technicians who have measured the damage report a loss of 30 to 40% pump efficiency by year 5 in phosphate-free systems. The machine does not announce it. It whispers. Dishes come out spotted. Cycles sound different, slightly longer, slightly louder, easy to ignore. Until one day, the dishwasher fills and never drains. A technician in Cincinnati with 31 years of experience put it bluntly. He stopped quoting repairs on what he calls post-phosphate machines. Anything built after 2010, because the failure is not isolated. Older machines, pre-ban, fail in simple ways. A seal, a switch, a heating element, $40 in parts. 30 minutes of labor, they go another decade. The newer machines fail differently. Internals coated in scale. Pumps worn down from years of strain. Heating elements operating at 20% above their intended load. When they break, the cost to fix exceeds the value of the machine. So he tells customers the truth. Replace it. This is the quiet rule in the industry. Everyone knows it. No one says it. The machines did not suddenly become worse. The chemistry did. Before 2010, Detergent did two jobs, cleaning dishes and protecting the machine. After the ban, it only does one, and the cost shows up in lifespan. Where a solid dishwasher once lasted 10 to 12 years, many now fail in 5 to 7. Same brands, same designs, same expectations. The variable that changed was not the appliance, it was the water running through it. Some manufacturers adapted better. European designs, built with stainless steel tubs and engineered for harder water, held up longer. They absorbed the stress, delayed the damage. But most machines were not built for this fight, and they are losing it. Here is where the story takes a turn most people never hear. Commercial dishwashers, restaurants, hotels, industrial kitchens were never forced to give up phosphates. From the beginning, the law carved out an exemption, written clearly, intentionally. Those machines still run detergents loaded with 20 to 30% sodium tripolyphosphate every single day. 50-pound buckets, month after month, cycle after cycle. The same chemistry that was removed from your home is still flowing through commercial systems in the exact regions where the ban began. The same drains, the same water systems, different rules. And the results are hard to ignore. Commercial machines run thousands of cycles every year, 15 years, 20 years. They keep going, pumps stay clean. Heating elements stay efficient. Internal parts look almost unchanged compared to residential units after just a few years. The difference is not engineering alone. It is chemistry. The exemption was not an accident. The food service industry would never accept a 5-year lifespan. Their margins depend on reliability. Their operations demand it. They have representation. They have influence. Homeowners do not. So one system kept the protection, the other lost it. And no one connected the dots publicly. Now consider the cost. A new dishwasher sits in a big box store for around $800. Run it on modern phosphate-free detergent in hard water, and it may last 6 years. That breaks down to roughly $133 per year. That does not include installation. It does not include time off work waiting for delivery. Run that same machine under different chemistry, conditions closer to what existed before 2010, and the lifespan stretches to 12 years. Now the cost drops to about $66 per year. The machine did not change. The math did. The difference is not subtle. Over time, that $800 purchase behaves like a $1,600 expense when lifespan is cut in half. And most people never realize why. There are ways to push back against it. One option is using a detergent that still contains sodium tripolyphosphate at levels around 8 to 12% by weight, similar to what standard formulas used in the 1980s. These are harder to find in stores due to varying state regulations, but they exist and are sold through alternative channels. Another approach is simpler and far cheaper. Trisodium phosphate, often sold as TSP in hardware stores as a paint cleaning product, remains available. A 2-pound box costs about $10 and can cover roughly 400 dishwasher loads. Adding about half a teaspoon alongside regular detergent introduces the same mineral binding effect that protected machines for decades. Calcium and magnesium are captured before they can settle. The dishes improve, the machine runs cleaner, the cost drops to roughly 3 cents per load. There is also maintenance. Once a month, an empty cycle with citric acid, about 3 tablespoons, run on the hottest setting helps dissolve any scale that has begun to form. Heating elements, spray arms, pump housings, all cleared before buildup becomes damage. Vinegar is often suggested. It works on scale, but it degrades rubber seals over time. Citric acid does not carry that risk. For households already using water softeners, much of this battle is already won. Soft water removes calcium before it ever reaches the machine. In those cases, even phosphate-free systems can stretch to 12 or 15 years. But in regions with hard water, places like Phoenix, Las Vegas, San Antonio, much of the Midwest, large parts of Texas, the difference becomes unavoidable. Hard water accelerates failure. Chemistry determines survival. There is no defect stamped on the machine. No recall, no warning label, just a silent shift that happened in 2010, an environmental decision that solved one problem and quietly created another. And unless you know where to look, you will never see it coming. If you care about how long your machine lasts, check what is under your sink. Read the label. Look at the ingredients. Because the difference between a dishwasher that survives for 12 years and one that fails in 6 is not always the machine itself. Sometimes it is what runs through it,